I'm going to speak about water quality and how we can treat the water after the nice pump that we saw before. And we have sometimes to purify that water, to treat it. But normally the people think we are living in the blue earth, the blue planet, and in fact two parts or three of our world are composed by water. But normally the 97% of water is in the ocean, so is salty, and it is impossible for us to drink it. So we have some problems, and also it is sometimes difficult to find good quality of water because is as ice, as in the groundwater, and very deep, and so it's quite difficult to find it. And also we have to analyze that there is a bad distribution of the water around the world, or a large part of the world where the water is not available, and we can see on your right the distance that sometimes there are between the people and the first catchment of water. And so in the last few years, decades, the people start to think about to have desalination. And desalination is a technique that try to take out the salt from salty water to have pure water and have this substance to give to the people. And for have the desalination technology is a strong water treatment, and with high technology normally, with high expense of energy, is very expensive also to have it. And but in the last years, for that bad distribution of water, these techniques are growing very fast. In fact, if we think that right now there are around 16,000 plants with over 45,000 cubic meters per day of water treated, and with a market that is increasing very fast, that right now is around 90 billions per day of euro. But as I said before, the desalination is a technology that needs a huge investment for the plants, for the technology, for the techniques, for the as knowledge also. And in this way, only the rich countries and the more developed could offer to pay water from the desalination plant, and also can maintain it. They can operate with this technology. So it was necessary to find a solution, a way to have pure water or drinkable water that is easier to the development country to have pure water from a bad quality of water. And also another problem is in fact the distribution. In fact, only the big cities can have a water grid, can have potable water, and it's quite difficult to find a good quality of water in the countryside or in isolated places. So we have to find small small plants, easier to maintain it, and also in the same times that are can be put in isolated places. The desalination is composed, first of all, from two main techniques. One is with membranes that, for example, RO, reverse osmosis, or thermal process. In the thermal process, we means that normally the salty water or the wastewater, we heat it, and after we collect the vapor and we condensate it, and we have pure water. In one of this technology that I underline is solar still. I'm going to explain you what is a solar still. The solar still is looks like a simple greenhouse where we put inside the water. Here the solar energy enters inside the greenhouse, and through the greenhouse effect we have an evaporation of the water. We condense the vapor, the steam condensed in the internal surface of the transparent cover, and we collect the pure water. The salt remain on the bottom, in a black bottom basin, and we have in this way pure water in an easy way, and also in an easy technology, we can say, and easy also to understand. That is, this is the main issue for the people in development countries. So the solar still have some advantages. First of all, the lack of external energy, so they don't need electric grid because they're working only with solar energy, and this is very interesting for the isolated places where normally the electricity or petrol or hydrocarbons are not present, so it's difficult to have this energy possibility to use electric energy. And also this system, when we buy the solar still, after it doesn't have cost for the production of water, because all the energy and the process is made from solar energy. And in this way we can think that is an environmental friendly approach, because we don't use chemicals, we don't use products that needs a lot of external energy or hydrocarbons consumption. Also, we have a low level of technology because it's quite simple to build it, as we saw the pump before, and it is easy to maintain it. But on the other hand, we have some limits. First of all, is we need wide areas to have a good amount of water. In fact, this is due from the few energy per square meter from solar radiation. We have a high initial expense to pay to build the greenhouse. But we are thinking that after we don't have any more cost for the production of pure water. We have a vulnerability to the bad weather. In fact, the production and the yield of pure water is decreased very fast with a bad weather, and also is not suggested to put this system in a northern part of the world, where the sun and solar radiation is very low. But from this point, we start and we apply, we try to find a new way to improve the efficiency of the solar still, and to limit the necessity of area to build it, increasing the increasing the production and the yield per day. First of all, we catch the salty water or wastewater, and we put inside this new kind of solar still. Here the salty water flow inside the black basin, and the solar radiation enter inside the greenhouse. The energy, the heat the water, and we produce vapor. The vapor is collected out by the suction of the air through a small fan, and we condense it with a heat exchanger with the water that we are collecting, that is quite cold. In this way, we improve, we force the thermodynamics processes inside the solar still, and in this way we can have a major yield per day. In fact, a common solar still that I spoke before has a production around 4 or 5 liters per square meter per day, with an efficiency, thermal and energy efficiency of around 45–50%, and needs maintenance. And the maintenance is due from that each day we have to open the system and take out all the salts that stay inside the basin. The new solar steel that we are studying had shown that we can have a production on yield around 10 liters per square meter per day with an efficiency of 56%, and don't need maintenance because we have a continuous flow. In fact, as I showed you in a video before, the water continuously enters from one side and goes out into the other side without and we take out the water before the saturation point of the salts inside the solution. In this way, we don't have solid salts inside the solar steel. In this way, we don't need maintenance and the system works autonomously. In this way, also, if we collect all this information, the system has been one idea for development of humanity from the United Nations because it has some good advantages. First of all, don't need maintenance. Also has a low environmental impact, is easy to use for the local people, has a high scalability. So we have some modules so that we put a parallel and we have more production, has a good efficiency, but also there is this program that the name is IDEAS, that is a United Nations program, that wants to catch that technologies that are easy to use, but also are can be constructed by the local people and managed by the local people. And for this way, this new kind of solar steel became one of these ideas for the development of the humanity. And I will show you after some example of application of this and cooperation about this solar steel. First of all, we have done some experimentation with the University of Foscari in Venice. We have done 3 prototypes. We are improving the solar steel. We are testing it. And after we move to some countries that now I'm going to explain to develop and to test it exactly where where is our target. First of all, the idea of the project was to collaborate with some NGO, Italian or international NGO, in different places of the world with this aim. First, to use local labor, to explain them how to build it, how to maintain it, and how to use it, and using local materials to solve the global problems that they have in different places around the world about the water quality. For example, here you have an example from Peru. In Trujillo, we built this solar steel. And there is a big problem about arsenic in pollution in the water, in the groundwater, from the mine that are the mine factories that there are in that area that are polluting the groundwater. And in this way, we explain to the people how to build with both the material in the market of the villages, and after we build this solar steel that we put on the roof of a small school, and we are giving the water to the children, to the students that are studying there. And from this first test that we have done, we discovered that a great improvement of this solar steel is that normally the people, when we give them high technology, that is quite close, that is difficult to understand, the people don't believe it so much about the water. If we think that normally the people drink water, especially in Peru, they drink water that is transparent as our water, but they don't understand that inside there is arsenic that is quite is not so good for the health. And but looking exactly the process, because it's exactly as the normal water cycle, where there is the sea, and the sun heat it, and after we have the clouds and the rain. They see inside this solar still that is transparent all the process, and the people start to believe more about the purification process. In the same way, we have done another collaboration with a local NGO of Venice in Burkina Faso. There the pollution was caused of the water was caused by iron inside the water. There was easier to speak, to explain to the people how, why we are going there to give them this water treatment plant, small water treatment plant, because the water was completely red. And so after they saw that the water became transparent, and so they believe a lot about this. And we have operated in the same way. We built it, we constructed there, we teach them to the local people how to build it, and with local materials. And right now, this is a small factory. It's quite strange, but it's a factory, it's a laboratory. They start to build there and put in the market, in the local market, and diffuse it around the country. We have done another test, another collaboration also in Palestine. Here the situation was more difficult because there they need it because they are drinking salty water. They don't have pure water, and also there is a lack of water. Another big problem also, there is a quality of the water, but also the quantity of the water. There the lack of water was very deep, and it was very salty. And also there are some geopolitics problems that don't permit to the local people to have good access to the water. There also we operate in the same way. They built it, they constructed, and they put it in a local and really isolated place, as you can see on the right bottom of the place. We are in the desert area, and we gave the pure water to the local community that lives in that tents, and they need it. Also easier system, easier to move for problems with the other communities. So after this, we are developing right now a new stage to understand where it can be interesting the diffusion of the solar still around the world. Developing a global index, economical and social index, that is constituted by 5 sub-index, and that take in account different problems that we analyze, and also different index. And the sub-index are that we are taking during our analysis is environment, social, energy and water, and economy. And we are computing all these indexes to have where can be interesting the diffusion of solar still, but more in general, simple and easier technologies about the water treatment around the world, especially with the aim of isolated areas and with difficulty to have access to global grids, water grids, and with a scarce quality of water in general. And these are the first results, but we are developing better this index to have better results. Thank you for the attention, and if you have any questions.